Hello everyone. In this session of CCNA series, I will discuss Network Address Translation, also known as NAT. As you know, IP version 4 addresses have 32-bit address space, which allows a total of 2 raised to 32, approximately 4.3 billion IP addresses. While this might sound like a large number, but in the early 90s, the commercialization and rapid growth of internet resulted in a shortage of available IPv4 addresses, which uh, because of which routing tables of the routers on the internet were doubling annually. And without some changes, the incredible growth of the internet in the 90s would have been stifled. Several long-term and short-term solutions were created. The short-term solution included CIDR, private addressing, and NAT. CIDR, also known as classless interdomain routing, which helps reduce the size of routing tables by aggregating routes and allows ISP to reduce the wastage of IP addresses by assigning a company like a subset of a network number rather than an entire network. Whereas a private address is intended for internal use, like within a home or organization, and can be freely used by anyone. However, private addresses can never be routed on the internet by assigning a like you cannot route it on the internet. In fact, internet routers are configured to immediately drop traffic with private addresses. And the third one is NAT, which we are going to discuss in detail in this session. Works closely with private addressing. So let's go ahead and discuss about NAT. NAT, also known as Network Address Translation, allows multiple devices within a local network that has a private IP address to share a single public IP address for communication with external network such as internet. Here you can see I have a server 172.1.1.10 that is on the internet, and I have my private PCs on my private network on the left side. So what NAT does is NAT translates or changes IP addresses inside a packet as it passes through a router. As you can see, the source IP address is changed when it passes through the NAT router. So NAT changes the typically private range addresses used inside an enterprise network into addresses from the public IP address space. In simple term, I can say a NAT is a process that involves translating private IP addresses into public IP addresses. And this reduces the number of required public IP addresses used by each organization or a company. Let's go ahead and discuss some of the NAT terminologies. Specific terms are used to identify the various NAT addresses and nodes. The enterprise network that uses private IP addresses and therefore needs NATing is inside part of the network. And the internet side of the function is outside part of the network. On the left side, you can see the inside part, and on the right side, you can see the outside part. Cisco look at the types of NAT. There are three types of NAT and can be implemented using one of the three methods, such as static NAT, dynamic NAT, NAT overloading, or PAT. Let's go ahead and discuss about static NAT. Static NAT allows the user to configure one-to-one mapping between a specific private IP address and a public IP address. It creates a fixed translation of private addresses to a public address. Let me take a scenario where the router named NAT at the end of the enterprise network is connected to the internet. As you can see here, host in the enterprises wants to connect with the remote server on the internet. The remote server IP is 172.1.1.10 and the host IP addresses are 10.1.1.1 and 2. So the NAT router has statically configured a mapping between private IP address, that is 10.1.1.1, and a public registered address, that is 200.1.1.1, for communication with the server that is on the internet, because we cannot use the private IP address to communicate with that server, right? So NAT router changes the source address of host A of 10.1.1.1 to 200.1.1.1, as you can see on the picture. Once the packet passes through the NAT router, the source address is changed. And another thing, for example, if I want another host to communicate with that server, then a second IP host with static NAT requires a static one-to-one mapping with the second IP address in the public address range. So here you can see in the table 10.1.1.2 is translated to 200.1.1.2. So one of the major concern with static NAT is for each IP host you need to have a publicly registered IP address of for internet access, which completely defeats the goal of reducing the number of public IPv4 addresses needed. And this is where dynamic NAT comes into picture. Okay, in dynamic NAT, multiple private IP addresses are mapped to a pool of public IP addresses. As I said, multiple private addresses are mapped to a pool of public IP addresses. You can see on the left side I have a /24 network and I have a pool of like 4 public IP addresses. So it allows for many to many mappings. So the NAT can be configured with more IP addresses in the inside local address list than in the inside global address pool. The router allocates addresses from the pool until all are allocated. Now I have 4 public addresses, so I can allow at a time only 4 mapping. And if a new packet arrives from yet another host, for example 10.1.1.3 or 11 outside this inside local range in the table, then the NAT router will discard the packet because it doesn't have any extra public IP addresses, and it has to wait until the host IP addresses are released. So dynamic NAT is usually configured on a router that maintains a group of public IP addresses in a network address translation table. And for each outgoing packet, the router replaces its source address, that is a private IP address, with the first available public IP address. Dynamic NAT reduces the problem to some level, but if you have a large percentage of IP hosts in a network that needs internet access, NAT still requires a large number of registered public IP addresses, again failing to reduce the IPv4 address consumption. This is where the third one comes into the picture. The NAT overload feature, the NAT, you can call it NAT overloading or PAT. NAT overloading, also known as port address translation, is designed to map multiple private addresses to a single public IP address, that is many to one, by using different ports. As you can see in the table, uh, the inside local addresses are like 4 hosts, but the inside global uses the same public IP address with different port numbers. So in other words, I can say a single public IP address can be used for several internal private IP addresses. Hence, the term overloading. So when PAD creates the dynamic mapping, it selects not only an inside global IP address but also a unique port number to use with that address. As you can see, 10.1.1 is using port number 49711, and same the public IP address uses the same port, right? Similarly, for other hosts, the port number is different. Got it? So the NAT router keeps a NAT table entry for every unique combination of inside local IP addresses and port numbers, with translation to inside global addresses and unique port number associated with the inside global address. So NAT overload can use more than 65,000 port numbers. So imagine how we can reduce the consumption of IP addresses. And PAT by far is the most popular option and is one of the main reason why the IPv4 address space has lasted till now. It's cost effective as thousands of users can be connected to the internet by using only one real global public IP address. I hope this was informative for you. Thank you for watching. If you have any queries, please do let me know or you can reach me anytime. Thank you.